All right, so let's go back now and look at how we examine the behavior of these functions when we are near the vertical asymptote. In our function, y equals x over x minus 3, we know that we have at x equals 3 a vertical asymptote. The reason, of course, we know that is that at the value x equals 3, the numerator is fixed, right? The numerator is defined, but the denominator becomes 0. That gives us that behavior. So how do we examine that behavior? Again, we make our substitution. We're going to take the limit as x approaches 3, this time from the right, of x over x minus 3. So if we make our substitutions, we've got a number approaching positive 3 in the numerator, and we've got a number approaching positive 3 in the denominator, but we're subtracting 3 from that. Now remember, as we're approaching 3, a little plus symbol, that's a positive number. That's positive 3. In the denominator, however, we're taking a number slightly larger than 3, say 3.01 minus 3, right? That means we're coming close to 0 from the right. We get a positive value over a positive value. This function tends towards positive infinity as we approach x equals 3 from the right. Let's compare that to limit as x approaches 3 from the left of x over x minus 3. Again, making these substitutions, I'm going to put in some number approaching 3 from the left, divided by some number approaching 3 from the left minus 3. Don't be fooled by this negative symbol up here, right? This is still positive 3 in the numerator, regardless of how it looks with that negative symbol. The only thing that negative symbol is indicating to us that we're going to take numbers that are slightly smaller than 3, say 2.9, and subtract 3 from that. It means we're going to get a number very close to 0 from the left-hand side. And so that value, we consider that value right there to be a negative. Right? It's only when it's attached to the 0 that the positive or negative makes a difference. And so in this case, we're having a limit that approaches negative infinity. All right, so now let's look at something that's a little bit more complicated here. We've got this limit as x approaches 2 from the right of x minus 2 over x squared plus x minus 6. Well, why are we approaching 2? Well, let's take a look at this. Remember, whenever we're dealing with these limits, we sometimes want to rewrite the function so that we have it in the factored form. So let's do that before we start. We're going to take our function x minus 2 over x squared plus x minus 6 and factor the denominator. So let's look at our limit here. The limit will be taken as x approaches 2 from something slightly to the right of 2. We've got x minus 2 in the numerator. No factoring takes place there. But in the denominator, we have, let's see, 2 linear factors that multiply together to give us x squared. Well, that's going to be x and x right here. And multiply together to give us negative 6, but add up to positive 2. That would be negative 2 and positive 3. So we don't actually have a vertical asymptote at x equals 2. What we have right here is a function that is undefined at x equals 2. It's not a fixed value, but won't behave as a vertical asymptote. And the reason why is, yeah, you said it, that's because the denominator and the numerator would be 0 at that point. So all we're really interested in what happens to the function at this point. Well, as x approaches 2 from the right, we're going to get 1/5. Right? This is our limiting value, so this is not a vertical asymptote. Where would a vertical asymptote exist? Well, that's right. We look at the denominator right here. We say x plus 3. And if we were evaluating the limit as x approached 3, then we would have a different story, sort of similar to what we have in the numerator.